Okay, so today's lesson will be on sets. Today's lesson will be on sets. Actually, this is our first stream. Yes, our first stream. So there might be some little challenges when it comes to getting the connections right. But just join with us, and hopefully, we are going to learn a lot at the end of this lesson. Because this first stream is going to give us an idea about how all of these things work and things we can solve or things we need to correct. So let's get started. Sets. Let me open my notes. So if you are joining, you are welcome. And if you've been waiting, you are also welcome. And thanks for your patience. Yes. You know, you don't have control over all the internet and all those stuffs. You know that. So, but I'll urge you to get a pen and your notes, because you are going to do a lot of solving. Yes, you write a lot. I'll do my best to give you more examples. And when I give you a question, try and solve it and leave your answer in the comment section. I'll see if I'll be able to read some of your comments. I'll see if I'll be able to do that. So I think I should get my laptop on hand so that I can join along the line and be seeing your chats. Yes, so let me make arrangements to put my laptop somewhere. But so you to also get your pen ready. Let me put the laptop here. Good. So I hope you have your pens. Do you? Have you got your pens? Yes, pen and paper. Our lesson is set. But let me join on the laptop so that anyone who joins the stream or anyone who joins the class, and if you also write your answer in the comment section, I can actually see and give you a thumbs up, because I know you are going to perform exceptionally well in this class. Yes, I'm sure. But before we start, I have some questions for you. Suppose you meet something like this in your exam. I'm going to give you a simple example. Suppose you miss something in your exam, something like this. Let me put this. You made something like this in your exam. Root of 9. And you are asked to write the answer. What will you write? Root of 9. Suppose you made something like that. Root of 9 in your exam. What will you write? So I'd like to see your answer in the comment section. Yeah. Root of 9. What will you write? By the way, give me a minute. Let me also join the chats as all of you have. Just give me a minute. Good. So root of 9. Good. Did you get 3? In the square root of 9, did you get 3? I'm sure you got that. Square root of 9, did you get 3? Good. So write in the comment section. I haven't got any answer yet. Or your answers have not appeared. Square root of 9. If you are wondering how we got that, take note of this. We are actually learning set, but I want to make sure the basics is clear for all of you. I want to make sure the basics is clear for all of you. You see this symbol, this symbol means 1/2. This symbol. This is what it means. Take note of that. And this 3, you know that in indices, this 3 is the same as 3 times 3. You already know that, right? You know that this 9 is 3 times 3. And 3 times 3 means 3 exponent 2. Do you know that? I'm sure you do, right? Then we have this 9. This 9 is 3 exponent 3. And it is in the square root sign. It is in the square root sign. So we can write this as 3 exponent 2 in the square root sign. But this square root sign, this thing is the same as 3 exponent 2 all exponent half. Do you get that? 3 exponent 2 And then there's brackets and there's exponent of half. Good. If you got that, then that means you have 3 exponent 2 times 1 over 2. And these 2 can cancel these 2. The 2 has cancelled the 2. So now I have 3 exponent 1. That's why we got 3. Did you get that? So that is why the square root of 9 is 3. This is easy peasy. Let me clean that really quick. So that's how we got square root of 9 is 3. So let me clean this side. As I'm writing, try and follow the lesson as I'm doing the explanations. Good. Try and follow it as I do the explanation. So let me clean this side. I'm going to give you another one. We are trying to build the foundation so that you understand and be able to connect or understand what surd actually means. So in our class, we are not interested in being able to just solve questions. We don't, that's not our main goal here. As you are solving the question, you actually understand what you are doing. So take note of that. This is our next question. Suppose you have square root of 16. What would be the answer? Square root of 16. If you know, write in the comment section. Let me see. If you are watching, you can write in the comment section. Some people say they've not been able to join. Let me see. I think someone says he's not been able to join. Okay. Well, I think maybe the technical issue I encountered has actually affected some students joining. But better still, this will give us the foundation to know how to do it better next time. So the square root of 16, what will you write? What is the answer? Square root of 16. You know the answer is what? The answer is 4. What about square root of 25? Do you know what the square root of 25 is? Square root of 25 is what? 5. And how did we get 5? You see, this square root of 25 is the same as 25 here. This 25 is the same as 5 times 5, which is 5 squared. So this square root of 25 is the same as 5 exponent 2. And these 2 will cancel the square root. So that's another way of thinking about it. This 25 is the same as 5 to the power 2, and it is under the square root sign. So the 2 will cancel the square root, and then that's all. Do you get it? Good. So these are all easy numbers. These are familiar numbers. So you would say, we want to learn surd, and you are giving us these examples. Give us something difficult, something challenging. Don't worry, you need to understand the foundation. If you don't get the foundation, if I'm even explaining surd into detail, you struggle a lot. You struggle so much. But I don't want you to struggle. So let's go. Let me clean this. So now we know that the square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Now, here's when it gets very interesting. And it gets interesting really quick. Now, you got it easy when I gave you square root of 9, square root of 16, and square root of 25. Now, let me give you something like this. Square root of, let me go for something very interesting. Square root of 2. What is the answer? Square root of 2. What's the answer for square root of 2? Do you know it? Good. What about square root of 5? What is the answer? Are you going to get a whole number? Square root of 2, you will not get a whole number. You will not get a whole number. Unless you use your calculator. What about square root of 5? Will you get a whole number? You see, these numbers, square root of 2, square root of 5, they are not that easy to find. But when I gave you square root of 9 that I gave you earlier, you knew square root of 9 is 3. You know that. But square root of 2, you don't know. Square root of 5. Actually, you can solve it but not get a whole number. So that's the whole idea. Square root of 2, you won't get a whole number. Square root of 5, you will not get a whole number. So any number of this form in square roots that you cannot get a whole number for, that number is called a surd. Is that clear? I hope that's clear. I'm sure you got it. So if you have a square root, a number under a square root, and then you can simplify it into a whole number, then that number is known as a surd. So what is a surd? Let me read the definition for you here. A surd is a root that cannot be written exactly as a whole number or a simple fraction. So keep that in mind. So a surd is a root that cannot be written exactly as a whole number or a simple fraction. So if you look at this square root of 2, if you use your calculator, you are going to get decimals. And square root of 5, you are also going to get decimals. So today's lesson is basically about understanding surds and how to simplify them, how to add and multiply and divide them. So depending on where we get to before I get tired, then we'll stop. So let's start with the very, very first type. But before we look at addition of sets, let's look at types of sets. Types of sets. So far we've established the fact that if you have a number, a square root of a number, and then you cannot simplify it into a simple whole number, then that number becomes a surd. Good, like square root of 2, square root of 5, they are also square root of 7. They are irrational and they are surds. So let's look at types of surds. We have simple surds. For example, square root of 2, square root of 5. They are all known as what? Simple surds. Then we have another example like 2 square root 3. So we have square root of 3, but in front there is 2. So 2, then square root 3. Or we have 5 square root 2. These are known as mixed surds. And I think you get the point. So there is this and then there's a number. So it's a mixture. So this is a simple surd, something like this. You have a square root that the number is inside. It's a simple surd. But if you have a surd, then there is a whole number multiplying the surd. Then you have what? A mixed surd. Then we have similar surds. Two surds are said to be similar if the number under the square root sign are the same. For example, if we have 2 root 3 and 7 root 3. 2 root 3 and 7 root 3. So 2 root 3 and 7 root 3 are known as what? Similar surds. Similar surds. So these are known as similar surds. So take note of this. So this and this are similar surds because of this. So we have square root 3 and what? Root 3. So we have 2 root 3 and 7 root 3. So because of these 3 here, they are known as what? Similar surds. And one interesting thing about addition of surd is this. Only similar surds can be added. Now take note of this lesson. This lesson we are having at the moment might look like a very fundamental and simple lesson. But trust me, if you don't understand the basics, you'll find it difficult when it comes to complex questions under surds. So pay attention to that. This and this are similar surds. Why are they similar surds? They are similar surds because of this root 3 and this root 3. So if you have a number like this, let me clean and have some more space for working. If you have something like this, let me give another example. And I'm sure at this point, you should be able to give some examples of similar surds. If you have something like this, 3 root 5, and then 7 root 5, these are known as similar surds. Why? Because of this 5 and this 5 here. They are known as similar surds. So when it comes to addition of surds, we can add only similar surds. Pay attention to that too. If the surds are not similar, you cannot add them. You can only add similar surds. So pay attention to that. And then we have unlike surds. For example, if you have something like 3 root 2 and maybe 7 root 5, these are unlike sets. They are unlike sets because of this 2 and this 5. Simply because the number under the square root sign are different. The number under the square root sign are different. But for this, if the number under the square root sign are the same, then they are known as similar sets. If they are different, they are known as unlike sets. And you cannot add them. You cannot what? Add unlike sets. You can only add similar sets. Pay attention to that before we move to simplification of sets. So I'm sure you got that, right? So let's move on to simplification of sets. Good. How to simplify sets. So let's wipe the board quick. So as an assignment for you, give me some examples of similar sets and examples of unlike sets. Similar and unlike sets. So you can give some examples if you are okay with that. Similar sets and unlike sets. So let's wipe this side. Let me see the students on WhatsApp. All the students on WhatsApp are saying they are not able to join. Okay, we'll address that later on. Yeah, we'll address that later on anyway. Maybe tomorrow we'll take the time and address that. Let me share that with the group again. So all those who are not able to join, this is our new link. Sorry, I shared the wrong link with you earlier. Good. So let's look at simplification of sets. Remember, in normal fractions, we have simplification of fractions. Simplification of fractions. Let me test your understanding of simplifications of fractions and see. You can have something like 5/10 and be asked to simplify 5/10. You might be asked to simplify 5/10. How will you simplify 5/10? Or what does it mean when your teacher tells you to simplify? It simply means reduce these numbers to become small. That's what simplification of a fraction means. It means what? Reduce the number so that the number will become small. Simplify the number. So you have 5/10. Simplify. It means look for a factor that can divide 5 and can also divide 10. That's what it means. So 5/10 is the same as 1/2. I know you already know this. So when it comes to simplification of sets, it simply means reduce the numbers in the set so that they become smaller. That's what it means. So the set that you have, just reduce the numbers so that it will become smaller. But one trick when it comes to simplifying sets is this. You should master perfect squares. To be able to simplify sets, you should master what we refer to as perfect squares. So we are going to look at some perfect squares that you should know. Some perfect squares you should know are 4. I'll explain what we mean by that. 4, 9. So 9, 16, 25, 36, 49. So 1, 2, 3, 4, 5, 6. So this number, this 4, is a perfect square because 2 times 2 will give you 4. So a perfect square is any number that you can get from multiplying a number by itself. For example, if you pick 2 as a whole number and you multiply this 2 by itself, you will get 4. So meaning 4 is a perfect square. And 9 is a perfect square because 3 times 3 will give you 9. Good. Then 16 is a perfect square because 4 times 4 is 16. And 25 is a perfect square because 5 times 5 is 25. Then this is 6, 6, 36, 7, 7, 49. So you should do for 8, 8, 9, 9. So you should know these perfect squares by heart. It's your responsibility. I won't know it for you. It's your responsibility to know these perfect squares by heart. And if you know them by heart, then simplifying said, Charlie, No matter how they say the question, you will kill it. You will murder the question. You will murder it too. No matter how they set the question, you will find it so easy to deal with it. I think you get the point. So just know this perfect square. 4, 9, 16, 25, 36, 49. Just know them. So just challenge. How should I even put it? Is it chew baba? Sometimes to pass your exam, they have to chew baba. You have to chew baba. Some things are there, you just have to know them. So if you know these perfect squares, then when it comes to simplifying set challenge, you will be able to answer any question at all. Trust me, you'll be able to answer any question. If you have joined this stream now, then if there are other students in our group that are saying they've not been able to join, so you can share with them. If you know them, share with them, especially those preparing for BEC. These are first stream, by the way. There are more lessons that I'll be preparing for. So let's go. So now I assume that you already know the perfect squares. Yes, I assume you already know the perfect squares. Good. So let's start. Simplification of sets. So let's pick our first example, how to simplify sets. How to simplify sets. Well, the first example we have, the example number 1. As for me, I'm going to be gentle with you, so I'll give you a simple example. That's square root of 8. Square root of 8. Simplify. First of all, you can see that 8 is not a perfect square. You can see that 8 is not a perfect square. Because if we check the perfect squares that I have, the 8 is not part. We have 4, 9, 16, 25. So it continues. 8 is not part. They also have 64 and co. So just check the rest. So 8. Now, if you are given a set and want to simplify, question number 1, you have to ask yourself, the number under the square root sign, can I split the numbers into 2 so that one of the numbers will be a perfect square? Did you get that question? Well, when we start solving, you'll get what I mean. So we have square root of 8. You have to check this 8. Can I split 8 into 2 numbers? 2 numbers that when you multiply, you can get 8. So that one of them will be a perfect square. For example, you know, what are the factors of 8? The factors of 8 are 2. We have 1 is a factor of every number, but I'm not interested, right? Okay, let me just write. We have 1 is a factor, 2 is a factor. Then we have what? We have 4 and we have 8. You know, if you multiply 1 and 8, you get 8, right? And if you multiply 2 and 4, you get 8. But if you check these 2 numbers, that means 2 times 4 is 8. So that's what I mean. Can you split these numbers into 2, this 8 into 2? For example, this 8 is the same as 4 times 2. So you've actually not changed the question, you see? You've not changed the question. So square root of 8 is the same as square root of 4 times 2. So this number, square root of 8, is the same as square root of 4 times 2. But here is the interesting thing. You see this square root, we have 4 and 2 under the square root. We can expand this one to be square root of 4 times square root of 2. So if you are solving with me right, square root of 8 is the same as square root of 4 times 2. So we've just opened up the 8 into 4 and 2. And then, since we are multiplying, we can pick them as individuals. So this square, the whole square of 4 times 2, we can pick them as individuals. Now you see why I said open up the 8 and say something. Look at this. Or why I said we should know the perfect squares. Can you see that 4 over here is a perfect square? 4. I know where 4 is a perfect square. Good. 4 is here. 4 is the same as 2 times 2 or 2 squared. 4 is the same as 2 times 2 or 2 squared. So that means this side, hopefully everything still appears. That means this 4 here can be written as this. Square root of 2 squared times 2. Good. Do you see it? So this square root of 4 is the same as square root of 2 squared, because 4 is the same as 2 exponent 2. 2 exponent 2 is this. Then what can we do? Let me use the red marker here. So this 2 on top of the 2 will cancel the square root sign. It has cancelled it. It has taken care of it. So let's continue on this side. So the 2 will cancel the square root sign. What are we left with? We are left with 2. So 2 times square root of 2. So the final answer is 2 root 2. Do you get that? If you get that, give a thumbs up. If you get that, let's see. Did you get that? 2 root 2. So that means when we simplify square root of 8, the final answer should be what? 2 root 2. If you've not gotten how we arrived at this answer, you can just write in the comment section. Maybe you don't understand something. Just let us know, okay, I don't get this point, and I can retake that. But I have our next example. That is square root of 18. Square root of 18. So like I said, as we are solving, be solving with us, because immediately we are done, I'll just clean it because we need more space for writing. So let's clean this side. Good. Simplification of surds. How to simplify surds. So let's wipe this quickly. We get this wipe out. Our next example, square root of 18. Square root of 18. Root 18. Square root of 18. Good. Question number 1. Can you open up this 18 to two numbers that when you multiply, you'll get 18? You should find factors of 18. Two factors of 18 that when you multiply those two factors, you get 18. But one of those factors should be a perfect square. One of those factors should be a perfect square. Do you know that 18 is the same as 9 times 2? Do you know that 18 is the same as 9 times 2? And if you know that 18 is the same as 9 times 2, then you know that square root of 18 is the same as square root of 9 times 2. You've actually not changed anything. No. You've not changed anything. You see how easy sets can be? If final year exam, you have set, Charlie, you should be happy. You should be extremely happy. Square root of what? 9 times 2. Now let's check what can we do. Look at this. This can also be written as square root of 9 times square root of what? 2. Square root of 9 times square root of what? 2. Can we do something to the square root of 2? Can we do something to the square root of 2? Look at the square root of 2. Square root of 2, square root of 9. Can we do something to the square root of 9, not square root of 2? Look at this. This 9 here is a perfect square. This 9 is a perfect square. 9 is the same as 3 times 3, and 3 times 3 is what? 3 squared. So this 9 can be replaced with 3 exponent 2. So 3 exponent 2 times 3 times this. Do you get that? I hope you do. Yeah. Simplification of surds. So we have square root of 3 squared times 3 squared times root of 2. Now what can we do from here? This 2 will cancel this square root sign. The 2 will cancel the square root sign. So we are left with the 3, this 3. So you have 3 times square root of 2. Then we can now write, I think, do you have space? No space. So let's continue from this side. So we will carry this for this side. So you have 3 root 2. So this is our final answer. 3 root 2. So if you simplify root 18, you'll get 3 root 2. As simple as that. Now, mind you, you need to understand this very well so that when it comes to multiplication of set, addition of set, you can easily handle them. Yes. If you see it like, if you understand these stuff, you'll be able to answer them easily. Now, let me tease you a little. For this, I'm going to give you a question. All of you should try. Let's see. Square root of 72. Square root of 72. Root of 72. Square root of 72. What will be the answer? Square root of 72. If you are to simplify, square root of 72. If you have to simplify, how will you simplify square root of 72? What's the answer? So question number 1. Can I open up 72? 72. So you have to look for 2 factors of 72. And those 2 factors, if you multiply them, you will get 72. But one of them should be a perfect square. That should always be the end goal. One of those 2 factors should be what? A perfect square. If one of them is a perfect square, then it becomes what? So easy for you to handle. So let's see. Are you aware that 72 is the same as 36 times 2? 72 is the same as 36 times 2. So these are some of the basic things you should know. So you can see why we say to be able to understand some topics in maths, your basics of mathematics should be good. So imagine someone struggles when it comes to multiplication. Such a person might even find it difficult to find out that 72 is the same as 36 times 2. I'm not sure somebody at your level has that challenge, but understanding these basics is so important. So let's move on. 72 is equal to 36 times 2. So that means this question, square root of 72, can also be written as square root of 36 times 2. We can write it this way. Square root of 36 times 2. And then we can take them individually as square root of 36 times square root of 2. We can take them individually this way. And it will just be fine. It will be just fine. Square root of 36 times square root of 2. Now, this 36, it is a perfect square. 36 is a perfect square. How do we know? This 36 is the same as 6 times 6, and 6 times 6 is the same as 6 squared. So we can replace this 36 with 6 exponent 2. So 6 exponent 2 times this. Easy peasy, right? Yeah. Then, what happens? These 2 will cancel this square root sign. That's what actually happens. Then we have 6 times root 2. So the final answer becomes 6 root 2 as the final answer. So in BC, or any final exam that you are preparing for, if you meet questions on simplification of surds, Charlie, you should easily handle it. So this is how surd is simplified. Simplification of surd. Let me give you this question. Just try your hands on this. We are not going to solve it. It's going to be a very simple example. Square root of 12. Square root of 12. What's the answer? Square root of 12. Root 12. Good. Square root of 12. Square root of 12. Just use or follow the steps that we've already applied. And do the same thing, and I'm sure you'll be able to do it. Just open up 12. And the final answer of square root of 12 should be something like 2 root 3. We are expecting the final answer to be 2 root 3. So solve and see if you will get 2 root 3. 2 root 3. So square root of 12 is what? 2 root 3. So we now understand perfectly how to simplify what's said. Obviously, the next thing we have to move on to addition and subtraction of surds. addition and what? Subtraction of surds. And after that, we'll finish up with multiplication and division of surds. So far, what have we discussed in this lesson? In this lesson, we've gotten to understand what surd actually is. So as a quick recap, when you have a number like this, root of 9, it gives you 3. Root of 4, it gives you 2. Root of 16, it gives you 4. These numbers are not surds. They are not surds. But if you have root of a certain number, for example, 5, and you cannot simplify it into a whole number or a simple fraction, then that number becomes a surd. We said that earlier. So for example, root 5 is a surd. Root of 3 is a surd because you cannot simplify them. Then also look at types of surd, simple surds like this one. Then we looked at unlike surds. For unlike surds, the number under the surd, the square root sign, are different. And similar surds, for example, we can have 3 root 2 and 5 root 2. They are similar surds because of these numbers. The square root sign, the numbers under them are the same. And then if you look at simplification of surd, for simplification of surd, we spoke about the fact that you can have something like, if you have a surd, look for how to open it up. For example, the square root of 12. Find 2 factors of 12, but one of them will be a perfect square. And then we discuss some simple perfect squares you should know, because these are how it's going to come in your exam when it comes to simplification of surd. So we'll end today's lesson here, simplification of surd. So practice on simplification of surd. Take your past question or your textbooks that you have. Practice on simplification of surds. Tomorrow, Jehovah willing, we'll be considering addition, subtraction, multiplication, and division of surds. I hope you get the point of everything we've discussed so far. This lesson will be made available for you. I'll edit and cut some part from it and make it available in the group. And if you have any question after this lesson, you can leave it in your various WhatsApp groups or leave it in the comment section. So thank you for tuning in and joining us today. And thanks for your patience. And unfortunately, most of you complained you were not able to join. Yes, most of you complained you were not able to join. And I take the fault for that because I think I gave a wrong link. And this is my first time doing live anyway. And simply because I did the setup, but I ended up messing up somewhere. So sorry for that. But hopefully tomorrow I'll learn from my mistake and most of you will be able to join. So if you have not been able to join this live because of that, do your best to watch this lesson, understand very well before tomorrow. Tomorrow too at exactly 9 or 9:10 thereabout, we'll be considering addition, multiplication, subtraction, and division of surd. So see you in tomorrow's lesson.